Let's see the question number 5 from paper 1. A conducting square loop of side L, mass m, resistance R is moving in the xy plane with its edges parallel to the x and y axis. The region y greater than equal to 0 has a uniform magnetic field B naught K. Magnetic field is 0 everywhere else. At time t equal to 0, the loop starts to enter the magnetic field with an initial velocity of V naught J meter per second. So considering this quantity K equal to B naught square L square by Rm, which of the following statements is or are correct? Okay. So see this loop, when the time is starting t equal to 0, that time this loop trying to enter the magnetic field region or almost on the verge of entering the magnetic field region. So as time starting, this loop is entering this region. So let us right now consider any general position of this loop when some portion of the loop is already inside the magnetic field. Let's say this is the condition of the loop at some random time t. So as the loop is sliding along y-axis, the magnetic flux is continuously changing, and due to that one EMF will be generated in the loop, and that is why the current will flow in the loop. Let us now find out what will be the EMF generated. Let's say I am right now looking from the top. This is our x-axis, this is our y-axis, and let's say the loop is, this is the condition of the loop right now entered. So one side is L. Only due to the movement of this side, the EMF will be generated, not due to the other two sides. So let us consider that this general position, the velocity of the loop is V. It is different from the initial velocity. It has entered the magnetic field region. So at this position, if the velocity is V, then magnetic field is upward. In this position, you'll see magnetic field is upward, or right now magnetic field is upward. So V cross B if we do, then the force direction is becoming this one, but the electrons will move in the opposite direction. So this side, this side of the rod will get the negative, this side of the rod will get the positive, and ultimately in the opposite direction of the electron flow the current will flow. That means this is the direction of the current flow, because electrons will ultimately accumulate on this side, and that is the opposite direction of the electron flow is the current flow. So current will flow in the loop. Let's say this is on general position. Right now V is the velocity, so current will flow in the loop like this. Okay. So if the current is flowing in the loop like this, then magnetic field is acting upward. Let's say the current amount is I. Then BIL will be the magnetic force on this L side. I L cross B. What is the direction of the force? L cross B. If you do L cross B, if you do, you are getting force in this direction. So ultimately you are able to see that BIL is the amount of force, but that is acting in the opposite direction of the movement of the loop. So ultimately this force will try to reduce the velocity of the loop. So this loop will be constantly deaccelerating. Not constant deacceleration, but will be constantly deaccelerating with some varying deacceleration, of course. So what is the value of I? I is E by R. R is the resistance of the loop, and E is the EMF produced due to the magnetic flux change. What is E? We know that is B into L into V, BL by R. This magnetic force acting on the loop will be B into I into L, that is B square L square V by R. That is the force on the loop, but that is acting in the opposite direction of the loop movement, loop velocity. So ultimately, if I draw the loop, right now we are considering that only one side entered inside the magnetic field. When two sides will enter inside the magnetic field, that time the net force on the loop will become zero, because these forces will act in the opposite direction, and ultimately net force will become zero. So option B is the one of the correct answers. Okay, now see, force is acting in the opposite direction. What is the amount of force? V square L square V by R. Now it is only having force in the opposite direction of the movement of the loop. So you can write that m dv dt, that is the mass into acceleration of the loop, that is going to be minus of v square L square v by r, because this force is acting in the opposite direction of the movement of the loop. So we can directly write dv by v is equal to minus of v square L square by mr dt. So v is at any random point, that is the velocity of the loop. So if we integrate dv by v, we'll get ultimately v square L square by mr integration of dt from 0 to t. Initial velocity is v naught, and let's say at any instant the velocity is v. So we can write that ln of v by v naught is equal to minus of v square L square t m into r. And ultimately we'll get v as a function of time, e to the power minus v square L square t by m into r. So see, it will take infinite time to make the velocity to be 0. So we can omit option number C. The loop will come to rest after infinite time, so there is no specific time we can tick. Now other two options we'll study. Now, similarly, this deacceleration or mass into deacceleration, we can write v dv dy also, because it is deaccelerating in the direction of y, so I am writing v dv dy is equal to minus of v square L square v by r. So see what I am getting. I am getting dv is equal to minus v square L square by mr dy. Now let's say when the loop will completely enter inside the magnetic field, that time the velocity of the loop is v, started from initial velocity v naught, so from 0 to L. Loop is started to enter, it will cover L distance. So v minus v naught, we are able to see that is v square L square mr into L. So ultimately I am getting v to be v naught minus v square L square by mr into L. Now in the question it is given that v square L square by mr, that is k. We'll put that. If we put that, we'll get k into L. So when the loop will completely enter inside the magnetic field, that time the velocity of the loop will become v naught minus kl. And after it completely enters the magnetic field, that time the net force on the loop will become 0. And after that it will continue with that speed. It will continue to move with that speed along y direction. Now let us study. V equal to, we got v naught minus kl. We got v equal to v naught minus kl, but initial velocity is given. Let's say we'll study this one, 3 into k into L. So that time 3 into k into L minus kl, that is 2 into k into L. That is the velocity of the loop when the loop completely enters the region. Now we have already found out our velocity as a function of time. That function of time is this one we have got. So I know when the loop completely enters the magnetic field, that time the velocity is, we have got, that is 2 into k into L. We'll study whether the option D is correct or not. So minus this value we can directly put kt. So let us find out. V naught will put 3kl minus kt, 2k into k into L, 2 by 3 equal to e to the power minus kt. So log will take log of 3 by 2 is ultimately kt. So t I am getting, the time it will take to enter inside the magnetic field completely, 1 by k ln of 3 by 2. That is the correct answer. So option B and option D is correct answer. Actually, option A is also wrong answer, because if we study this velocity properly, V equal to V naught minus KL, that is the velocity of the loop when it completely enters inside the magnetic field region, or just enters entirely in the magnetic field region. So if V naught is 1.5 KL, so ultimately we are getting some value of the velocity when it will enter completely inside the magnetic field region, that is 0.5 k into L. But it has given that it will stop before it enters. But so this is not right. So this is also wrong option. The correct option is option B and option D. Question number 6. Length, breadth and thickness of a strip having uniform cross section are measured to be 10.5 centimeter, 0.05 millimeter and 6 micrometer. Which of the following options give the volume of the strip in centimeter cube with correct significant figures? We will just multiply. Let's find out the volume. Volume is 10.5 centimeter. Everything will keep in centimeter only, into 0.05 millimeter. So 0.05 into 10 to the power minus 1 centimeter into 6.0 micrometer. Micrometer means 10 to the power minus 4 centimeter. That is equal to, if we multiply all these things, we will get 3.15 into 10 to the power minus 5 centimeter cube. Right now, you have to express the final volume, whatever you are getting, in correct significant figures. So, see which is the least number of significant figures. So, this is having 3 significant figures, this is having 1 significant figures, and this is having 2 significant figures. So, the deciding factor will be the 1 significant figure, or this is the limiting significant figure. This will decide the significant figure for the final result. So, that is 1. So, I should express the entire result in 1 significant figure, that is, so out of these options only one, option D, is having the 1 significant figure result, that is 3 into the power minus 5 cc. So that should be the answer, option number D. So next question is question number 7. Consider a system of 3 connected strings S1, S2, S3 with uniform linear mass densities mu, 4 mu and 16 mu respectively, as shown in the figure. S1, S2 are connected at a point P. This is the point where S2 and S3 are connected at point Q, and other end of the S3 is connected to a wall. A wave generator O is connected to the free end of S1. The wave from the generator is represented as y equal to y naught cos of omega t minus kx. A wave generator is sending wave towards positive x-axis. When the wave reflects from P, the wave will pass through these nodes, P, Q, all these nodes, and while passing these nodes, and these are the point of varying density. So one side is having mu density, another side is having 4 mu density. One side is having 4 mu density, another side is having 16 mu density or linear mass density. At this point, some of the wave will be transmitted, some of the wave will be reflected. So let us find out. When the wave reflects from P for the first time, the reflected wave is represented by this one. See, when the wave is reflected, the wave amplitude will be changed as well as this direction will be changed. So when the wave will be reflected from P, the wave amplitude will be changed. So some different amplitudes, this is alpha 1 into y naught, it is already given different amplitude, and it will have the pi phase angle difference. So wave direction will be changed as well as there will be some pi phase angle will be added. So this is the correct answer, first one. Second one we will examine. When the wave transmits through P for the first time, the transmitted wave is represented by this one, cos omega t minus kx. See, the direction given it is okay. Amplitude is also okay because amplitude will be changed. But see, the kx is not be the kx, because when the wave will be transmitted, that time the wavelength of the transmitted wave will change because the velocity of the wave is changing. So velocity of the wave in S1, if it is v, in S2 it will be root over of t by mu. If we do t by 4 mu, that time it will be v by 2 S2. So to keep the frequency same, the lambda will also change, because lambda here will be reduced to lambda by 2. So if lambda is changed, then k will also be changed, because k is a wave number. So it will be 2 pi by lambda by 2. That is 2 of 2 pi by lambda. So k for the transmitted wave will be 2k. But here it is given only k. So it is wrong. When the wave reflects from Q for the first time, the reflected wave is represented by this one. Reflection direction is not right. So this is not the right answer. When the wave transmits through Q for the first time, the transmitted wave is represented by alpha 4 y naught into cos of omega t minus 4 kx. We can take it as right. We'll see why. See, the direction is kept same. It is going towards the positive x axis only. The coefficient of x, that is given 4k. So from mu to 16 mu, if one wave is having velocity v in mu medium, in 16 mu density medium, the wave velocity will be v by 4. That means the k or the wave number will also be changed to 2 pi by lambda by 4, that is 4 of k. So it is given correct only. So option A and option D are correct answers.